Hale, today we're going to talk about the methods by which we can collect data, and specific the way that we can randomly sample in order to collect data. We talked about wanting to get a representative sample when we want to find something out about a population that we're unable to reach because it's so large, or the time constraints or the budget constraints. And so we want to make sure that our samples are representative of the populations of interest. And so there are 4 good ways to do that. We can take a simple random sample. We can use this thing called a systematic sample, a stratified sample, a cluster sample, and then I have crossed out here this convenience sample because it is a way of sampling, but it largely causes a sample that is not representative of your population. And so that's why I have it crossed out, because it's not really a good way to sample. So we'll talk about each of these individually. It's a good idea to pause, to write down the definitions, maybe listen first to me talk about them. As always, ask for help if you get stuck or I say something that might not be clear to you. So the first type of method is called the simple random sample. It's important that every member of the population of interest has an equal chance of being selected. And so the way that we do that is we assign a number to each individual. The easiest, most accessible example that for us is a student number. We can assign every student an ID, a 6-digit ID number. I think they're 6 digits. My badge number is 6 digits. If it's 5, that's all right. You get the point. Everybody is assigned a unique number, and then we can use some sort of technology. In our case, a calculator to randomly generate numbers. Randomly generate or pick numbers. So we have these 6-digit numbers I'll stick with. We can randomly generate perhaps 100. Maybe we want to get a sample of 100 students in this school, just a simple random sample. So we would randomly generate 100 student numbers. Of course, we'd want to make sure there was no overlap. So if we randomly generated the same number twice, we'd want to do an extra one. And then we would select those 100 students to either give our survey or look up information about. In systematic sampling, we again would want to give everybody a number. So I'll stick with assigning a number. We're going to randomly generate the first person. So if we give everybody their 6-digit ID number, we will randomly generate one 6-digit ID number, and I'll show you how to do that on the calculator. We will survey or collect information from that individual, and then we will sample every nth member or every nth student number. So that means like we choose what we want to count by. So maybe we add 10 to the first student number and then select that student, and then 10 more, and we'll select that student, and then 10 more, and we'll select that student until we have our sample, which I think I said 100. So we would do that for 100 students. Add 10 to their number every time, or take the 10th person above that student number, and then take the 10th and the 10th and the 10th. So When I say sample every nth, we will choose what that n is, whether it's every 10th person or every 5th person or every 4th person. So different from a simple random sample because we're not randomly generating 100 numbers. We're randomly generating one and then going from there, selecting every, say, 4th or 5th or 10th person to sample. A stratified sample is where we have some sort of characteristic in our population that would make us want to break that population up into smaller groups based on that characteristic. So again, we're just going to stick with the student population here. There might be something we're interested in that is your class, so freshman, sophomore, junior, senior. We can break the student body up into those subgroups that we call strata. It's a stratified sample. We break them into strata. And then in this stratified sample, so first we'll break into groups. We will group, in this case, freshman, sophomore, junior, senior. And then within each group, we want to do a simple random sample. So if we want to get to our 100-person sample size, we would break the school into freshmen, sophomores, juniors, seniors, 4 strata based on that characteristic of grade level, not necessarily age, but grade level. And then within each group, we're going to take a simple random sample. So we get a simple random sample of 25 freshmen, a simple random sample of 25 sophomores, a simple random sample of 25 juniors, and then another simple random sample of 25 seniors. So again, we'd have to go back to our random sampling and we'd number the freshmen, randomly generate 25 numbers, number the sophomores, randomly generate 25 numbers, so on and so forth. So this would be a way to get a representative sample of our school by getting students from each grade level. So it's possible that we randomly generate 100 students doing a simple random sample, and maybe we don't represent the sophomore population, and it's important. So this is one way to make sure that we get that grade level represented in our sample. Similar to that is a cluster sample. Again, we are going to be grouping, maybe not necessarily by characteristic. This is something we can do if we want to do a survey within the state of Virginia. We might cluster by county. So to take it back to our school example, we might cluster by first period, something that in the olden days we referred to as homeroom. So we might cluster by homeroom. Sometimes we have classes like AP classes, IB classes, language learner classes, classes that have extra supports, and we have all those classes during homeroom. So we think that we probably have kids of all ages in there. And so what we could do, each homeroom would be considered a cluster. We would randomly select clusters. So perhaps we'd randomly generate room numbers and the homerooms associated with those room numbers. Maybe we decide we'll select 10 of them. If we have on average 28 or 20 students in each of those and we select 10, we'll get about 200 students sampled. We'll randomly select 10 clusters, so 10 homerooms, and then we will collect information on everyone in the cluster. So I think I say in here, yep, we're doing a census of each cluster. A census is when we find something out about an entire population. So I might be using that word a little liberally, but in a stratified sample, we sample some people from every group. In a cluster sample, we sample some groups, but we sample everyone in those groups. These are definitely going to be the two that you want to make sure that you pay most attention to finding the differences in. And then again, I said I got that convenience sample once scratched out because it's not really the best way to do that. This is where we just sort of collect our information from people who are in sort of a convenient location. So if you've ever, this would be like me standing at the entrance of the second floor cafeteria and just asking everybody who walked by me who would pay me any attention, whatever question I wanted to know about. Like maybe it would be, how do you like the food in the cafeteria? And so why that might be bad is somebody who's actually going to the cafeteria to eat food might have different opinions than people who decide they want to go to the library for lunch, or even second floor and first floor cafeteria could be different. People who decide they want to just walk to the gas station during lunch or walk the halls or hang out in the bathroom. So we're not really getting a representative sample necessarily when we're not being thoughtful and we're just kind of asking people who walk by. Let me see here. I'm gonna skip this and come back to it. Um, Collecting data is an imperfect thing. We will do our best to mitigate any biases that might exist. So we would not want to convenience sample. If there was something about, say, grade level that was important to us, we'd want to make sure we do a stratified sample so we get a representative population or representative sample of our population. But errors happen, and what we get in our sample is not always exactly the same as what exists amongst our population. And so that's what we call sampling error. There's always variation between what we find in our smaller sample size and what actually exists in the entire population. And then we have other errors. So those errors occur just from the variation that exists between our smaller section of our population. And that's okay, that's going to happen. Non-sampling errors exist when we use bad methods or we don't pay enough care or attention to getting a representative sample to study. So these things are okay. Non-sampling errors are not really okay. We want to try and mitigate, and we want to try and adjust for those as much as possible so that we get good representative data. And so sorry to have skipped around here. I have 4 scenarios here where we sampled, and we have 4 good methods and 1 kind of meh method that I discussed in the lesson. Simple random sample, systematic sample, cluster sample, stratified sample, and then that crossed out convenience sample. So what I would like you to do is I would like you to pause and see if you can decide which sampling method we use in each of these. And then we will discuss that at the beginning of next class and see what everybody had to say and discuss why each of them is which method. As always, if you have any questions throughout this lesson or you want to ask something before you leave, before you're done, feel free. Please do not walk away confused if I can help you.